Welcome to this tutorial on the neurobiology of emotion. I'm speaking to you from the home of some friends of ours here on Lake Gaston near the border of the state of Virginia and the state of North Carolina. And being in such a lovely setting as this certainly brings to mind lots of emotions. And in this tutorial, we get to explore together what's going on in our brains when we experience a beautiful setting like this or some other kind of emotion. And I'll be speaking to you about some examples of some of the darker sides of our emotional experience. But let's have a balanced perspective and also consider those wonderful moments in life when we get to enjoy a beautiful lakeside experience such as this, and consider the brain basis of emotional processing. So I'll see you back in my own home shortly, and we'll have a chance to dive deeply into this topic then. Welcome to what I think will be a really fascinating tutorial on the neurobiology of emotion. This topic pertains to several of our core concepts in neuroscience. Of course, we are once again exploring the complexity of the human brain, but we will also be talking about a kind of intelligence. It's been relatively popular in recent years to talk about emotional intelligence, to recognize that within the domain of affective experience, there is a certain kind of intelligence or a certain kind of expertise that seems to vary across people. I'm not really going to talk about that, but I do want to at least buy into the idea that there is a dimension of intelligence that pertains to our emotional experience and expression. And indeed, like all other dimensions of intelligence, these faculties arise as the brain reasons, plans, and solves problems. And then lastly, I believe this core concept is certainly in view today as we talk about emotions and affective behaviors, and that is that the brain endows us with a natural curiosity to understand how the world works, including the world of our emotions and our human relations that are so critically dependent upon the means by which we can communicate using emotional cues as well as verbal cues. Well, my learning objectives for us today are several. I want you to be able to characterize emotion in neurobiological terms. That is, to characterize emotion as a form of associative learning. I want you to be able to understand something about the brain centers that appear to do this job of associative learning in the emotional domain. And two particular brain centers that we'll spend much of our time talking about today are the amygdala and the orbital and medial sector of the prefrontal cortex. So I want you to be able to understand how these structures participate in the experience and expression of emotion, and I'd like for you to be able to differentiate the role that each might play. And then lastly, I want you to be able to discuss the involvement of the limbic forebrain in decision making. And this will get us into really a fascinating discussion of really what is the relationship between emotion and reasoning. Are they really at odds the way we in the West and in the tradition of Western philosophy might have thought, or might they actually operate in some more synergistic way? Well, we will address that at the conclusion of the tutorial today. Well, let's begin by asking the primary question. What is emotion? Now, I've already talked some about how difficult it is to articulate the content of emotion using the conventional tools that are available to our explicit representational system, that is semantic symbols that can come to represent thoughts and ideas. Well, emotion seems to pertain more to implicit modes of processing rather than explicit, and perhaps this is why it is such a challenge to articulate in the same kind of detail with which we can, well, let's say, describe the sights and sounds of the bird who's singing up in the trees behind me. But this is a glorious problem that we face as human beings, is it not? Perhaps this is where artistic expression comes from, where music, where forms of literature such as poetry, where the visual arts, the performing arts might derive their principal inspiration from this challenge of conveying a sense of emotion without necessarily having at our command the tools by which we typically ascribe meaning to explicit content. Well, more on that as we go along here. But let's appeal to some thoughts from really one of the founding fathers of biological psychiatry, William James. What did James have to say about emotion? Well, more than a century ago now, James described it this way. He said, if we fancy some strong emotion and then try to abstract from our consciousness of it all the feelings of its bodily symptoms, we find that we have nothing left behind, no mind stuff out of which the emotion can be constituted. Now, I'm not necessarily promoting all of the ideas and concepts put forth by William James more than a century ago, but I certainly think he was onto something here by suggesting that if we want to understand emotion, we need to understand how the brain moves the actions and interactions of the internal bodily state. James went on to say that, I say, for us, emotion dissociated from all bodily feeling is inconceivable. So James was quite intrigued with the relationship between body and brain, between mind and body, and how that interaction might give rise to emotional experience. Well, James and at about the same time, Lang together came up with pretty much the same concept. And together, this is sometimes called the James-Lang theory of emotion. It's one of the very earliest neurobiological theories of emotion. And here's how this worked. Well, William James imagined that the trigger for an emotion would be some kind of stimulus that would activate our peripheral receptor system. So this could be, let's say, the sound of footsteps in a dark alley, rapidly approaching from behind. It could be an alarming somatic sensory stimulus. It could be a visual stimulus, or the combination of all of that. So this would be the proximal trigger of the emotion. But we're not yet there in expressing that emotion. So what James had in mind was that this emotion-provoking stimulus would be processed through our sensory systems, and this would lead to something like a reflexive activation of our motor system, both our somatic motor system and our visceral motor system. So smooth and striated muscle activities would be engaged. That would lead to yet a secondary sensory event where peripheral responses of these effector systems would be detected and sent back on into our relevant sensory divisions of the brain, principally the somatic sensory cortex and our visceral sensory cortex in the insular regions. These would be integrated, and it would be the integrated perception of this secondary sensory feedback that triggers the emotion. So in James's concept, the emotion then is elicited by peripheral feedback. This is why he so famously stated that we are afraid because we tremble. So note the causal direction there, that the fear is the consequence of the physical act of trembling. Well, these ideas were controversial right from the start. There were critics at the time who challenged this idea, and there are critics today who continue to find fault with this notion. William James emphasized the importance of smooth and striated muscle effector systems, not just in the expression of the emotion, but in the actual experience of the emotion itself. Remember, it's the secondary sensations derived from these effector systems that elicit the emotion in the James Lange theory. Well, one source of criticism in the early days of understanding the physiology of the central nervous system was, well, if this is the case, then people with spinal cord injury ought to be severely impaired in their emotional experience, and that didn't seem to be the case. And more contemporary critics continue to basically attack this idea from the same perspective, and that is by challenging the postulated obligatory interplay between the body and the peripheral structures. Well, I think these criticisms are well-founded, but potentially underestimate the potential of the brain to represent bodily action, and to do so in a vicarious way that perhaps makes this relationship between body and brain in the production of emotion non-obligatory. We'll come back and talk more about this as we explore a more contemporary notion that is built upon this James Lange theory of emotion. Well, I want to give you a neurobiological framework for approaching an understanding of emotion. And this framework will put us in a position to actually do experiments and test hypotheses that might begin to get at the neural mechanisms of emotion. And this framework is essentially proposing that we consider emotion as a form of associative learning. So here's how this might go. We imagine that emotions would result from the association of sensory stimuli with primary reinforcers. So the sensory stimuli, they might be interoceptive, that is, they might be derived from within the body pertaining to, let's say, visceral sensory signals derived from our gut and from other viscera of the body. They may be exteroceptive, derived from our interactions with the environment outside and be processed through our special sensory systems. The primary reinforcers are those experiences that have some intrinsic value to them. They may be rewards, which could be anything for which we might work, such as a pleasant taste or a tactile sensation. These reinforcers could be punishers, which would be anything that we will actually work to escape or to avoid. It could be an aversive taste, it could be a painful experience of one dimension or another. So the job then for building up an emotion would be to create some kind of association between primary reinforcers and sensory stimuli. And so here's how we imagine this might happen at the neuronal level. We believe that there are neurons in important structures in the brain. We'll spend a bit of time talking about the amygdala and the orbital medial prefrontal cortex. So we imagine that this might be a neuron in one such structure, such as the amygdala. So the amygdala in particular is well positioned to do this job of associative learning. It's receiving inputs from a variety of sensory systems. In fact, virtually all of the sensory systems provide more or less direct input into parts of the amygdala complex. Now, these sensory stimuli are in themselves neutral. They just might be sounds or sights or somatic sensory stimuli. But if those stimuli are present at the same time as a primary reinforcer, then we imagine that there may be some kind of associative learning that can take place. So again, the primary reinforcer could be that pleasant touch or taste, that aversive or painful stimulus. So we imagine via the convergence of very different kinds of inputs onto the same postsynaptic structures, we have the potential for synaptic plasticity to do the job of associative learning. Now, you'll recall the mechanisms of synaptic plasticity that we might have in mind here would include long-term potentiation, long-term depression, and in particular, if we're talking about building up an association of a strong stimulus with what is very likely initially a weak stimulus, then I hope you will recall the mechanism the impact of this sensory stimulus that was initially neutral and weak, but following associative learning might take on a life of its own due to the strengthening of the synaptic connection. Well, this might be a good time for a study question. So I'd like to remind you of what you learned way back in Unit 2 of the course, where we had a chance to consider in some depth the mechanisms of synaptic plasticity. So take just a minute and respond to this study question.